Welcome to my notes on volume of a rectangular prism. Okay, so as you probably remember from 6th grade, the volume is a measure of the amount a container holds. Okay, so the formula, as you probably also remember, is length times width times height. And later in this unit, we're going to discuss some key words that you'll see in word problems that also mean to find the volume without actually saying the word volume. So look at Prism A. The first thing I like to do is label the length, the width, and the height. And now we're going to complete the chart. So Prism A is right here, Prism B, and Prism C. So Prism A, the length is 3 blocks long. The width is 2 blocks wide. And the height is 1 block tall. So to find the volume, we do length times width times height, which is 6. And we're going to write CU for cubic units. And down here, we'll put a little key that says CU equals cubic units. So every time we write CU, you know that it means cubic units. So let's look at Prism B. We have length, width, and height. So the length here is 3 blocks long. The width is 2 blocks wide. And the height is now 2 blocks tall. So we do 3 times 2 times 2, which is 12 CU, or cubic units. Now, I want you to look carefully here. The length stayed the same, the width stayed the same, but look what I did to the height. I doubled the height, and look what happened to the volume. The volume also doubled because 6 times 2 is 12. So when we multiply something by 2, we say that it doubled. And the height can get multiplied by 2, and the volume can get multiplied by 2. Now let's look at the third prism, Prism C, and we have length, width, and height. So the length here, once again, is still 3. The width, once again, is still 2. But now the height is now 3 blocks tall. So 3 times 2 times 3, of course, is 18 cubic units. Now it's difficult to see how you got from 12 to 18, but let's look at Prism A. We started out with a volume of 6, and from Prism A to Prism C, the height went from 1 to 3. So we could say that the height tripled. And look what happened to the volume. 6 times 3 is 18. So we can say that the height tripled, and so did the volume. And this will always happen if we change one of either the length, the width, or the height. And we call length, width, and height, we call these attributes. So you will hear me say attributes over and over and over again in this unit, and I'm referring to length, width, and height. Okay, so these are describing the sides of the prism. Okay, so we call them attributes. Okay, moving on here. It says, what is the relationship between the change in height and the change in volume? So we can say as the height increases, the volume increases. And then, of course, the opposite of increase is decrease. So as the height decreases, the volume decreases. Okay, and we saw that relationship if we went from A to B to C, but if we went backwards, C to B to A, that's where the decreasing comes from. Okay, so it says, look at the 2 boxes below. How did the height change? So if we want to do that, we need to find out what the 2 heights are. So what I like to do first is label the length, width, and height when it's not already labeled for me. So this is the length, this is the width, and this is the height. So go ahead and label that. And then over here, the length, is 10, the width is 7, and the height is 8. So what I like to do, if it's asking me to compare the height, so I'm going to circle the height of both so they stand out. And the original height was 4, and the new height is 8. So what happened to the height? That's correct, it doubled. Because it went from 4 to 8, and 4 times 2 is 8. So we say when any thing gets multiplied by 2, we say that it doubled. Now, we're going to find the volume of both, and then we're going to describe how the volume changed. So the first thing I like to always do is write length times width times height, because that's the formula. Then I like to replace the letters with the numbers. So the length is 10, the width is 7, and the height is 4. And of course, 10 times 7 times 4 is 280. And since we don't have centimeters or inches or meters or feet, we're going to say cubic units. And then I'm going to circle my answers. So the volume is 280 cubic units. Now, moving on to the next volume. So we write the formula length times width times height. And we know that the length is 10. The width is 7, and the height is 8. So if we multiply 10 times 7 times 8, that will give us 560 cubic units. So now we have to answer this question. How did the volume change? So it went from 280 to 560. And hopefully you noticed that the volume doubled. So we can once again say it doubled. So we've discovered if we change one of the attributes, and the attribute we changed here is the height. So if we double the height, then it changes the volume by the same amount. So that's why the volume also doubled. Now remember, it's very important that we remember that this only happens if we only change one attribute. Okay? So if we change one attribute, whatever amount we change the attribute by, the exact same thing will happen to the volume. Okay, so turn to page 2. And this is slightly out of order. So what I'm going to do is I'm going to do this part first. So it says scale factor is the amount a measurement is being blanked by. Hopefully you were thinking multiplied by. And now that we know what scale factor is, now this will make more sense. When any one measurement is increased by a scale factor, then the volume increases by the same scale factor. And that's what we saw in the example we just did. Basically the scale factor doubled, or was 2, because we multiplied the height by 2 to get from 4 to 8. And so the volume also doubled. So we say they had the same scale factor. Okay, so look at example 1 here. It says find the volume of the prism below. Now, the first thing I like to do is label the sides. So this is the length, the width, and the height. And I always write the formula so I know what I'm plugging the numbers into. So length times width times height. And then I just look at my labels here. The length is 6. The width is 3. And the height is 2. So 6 times 3 times 2, of course, is 36. And my label is centimeters cubed. My label is always cubed for volume. And I didn't explain this. I should have explained this earlier. The reason why is I'm multiplying 3 measurements together. Length times width times height. So when I'm doing this, I'm multiplying centimeters times centimeters times centimeters. And so multiplying centimeters 3 times, and that's why I have an exponent of 3 here. Okay? Excuse me. Okay, now, It says the table below gives information about enlargements of the rectangular prism, but at the very end you'll see it actually gives a reduction. Fill in the missing values based upon the given scale factor. So we have to remember that the original volume was 36 because that is going to help us to fill out the last column. So what you're going to need here is when you're doing these notes, make sure you have a highlighter handy. If you're doing this, watching this video in class, you can just grab one out of the box. But if you're not in class when you're watching this video, just pause the video and find a highlighter at this time. Okay, so it says we have a height here, and we have a scale factor of the height, and we want to find the new height, which once we find the new height, we can find the new volume, and then once we have the new volume, we can compare that with the old volume to see what the scale factor of the volume actually was. So we learned above that scale factor means multiply by, so we're going to multiply the height times the scale factor. So we're going to do 2 times 2, which is 4 centimeters. And notice the height's always going to be 2 because that's the original height. And 2 times 3 is 6. So the new height for this prism would be 6. If the scale factor is 4, 2 times 4 is 8. So the new height is 8 centimeters. And 2 times 1/2, or say another way of looking at it is taking half of 2, which is 1 centimeter. Okay, now this is where you're going to need that highlighter. And what we're going to do is we're going to highlight the length, the width, and the new height, because those are the ones that we're going to multiply to get the new volume. So length, width, and new height, length, width, and new height, and length, width, and new height. Okay, we're not highlighting this column because that was the original height, and we already figured out the original volume above, which, if you remember, it was 36 centimeters cubed. So to find the new volume, we're going to multiply 6 times 3 times 4, which is 72 centimeters cubed. If you know what you're doing here, you can go ahead and pause the video and figure out the next 3 rows. So the next row is 6 times 3 times 6, which is 108 centimeters cubed. The next row is 6 times 3 times 8, which is 144 centimeters cubed. And then 6 times 3 times 1 is 18 centimeters cubed. Okay, now, to find the volume scale factor, we have to figure out how we got from the old volume to the new volume. Okay, so if you remember, the original volume was 36. So think about how you can get from 36 to 72. And if you said double it or multiply it by 2, you're correct. And so the scale factor of the volume would be 2. Now we've got to figure out how to get from 36, the original volume, to 108. And if you said multiply by 3, you are correct. So the scale factor would be 3. The next one, you're trying to figure out how we got from 36 to 144. And hopefully you see that if you multiply 36 by 4, you would get 144. So we say the scale factor of the volume would be 4. And last but not least, if you want to get from 36 to 18, you would have to take half. So hopefully you notice that the volume scale factor and the scale factor of the height were both the same. So note the scale factor of the height and the scale factor of the volume are the same. And we actually said that at the top of the page. Okay, now, hopefully, you will be able to figure out this next question based on what we've been doing. So, the makers of this container wanted to increase the volume by a scale factor of 2, or double the volume. Which of the following makes that possible? So think about what we just did in that chart. So could we square any measurement, which means multiply it by itself? Could we multiply all the dimensions by 2, multiply any one measurement by 2, or add the measurements and multiply by 2? So what do you think? Hopefully you said multiply any one measurement by 2. Now in the example we did, we were always changing one attribute. And the attribute I chose for that chart was height. But you're going to see on the next page that you don't always have to change the height. You can change the width and the length. But it's important to note that you're only changing one attribute. So if you want to double the volume, then you need to double either the height, or only the length, or only the width. Okay, so that's why we picked multiply any one measurement by 2. Okay, turn to page 3. And we're only going to do this top part here. We'll stop when we get to affecting the volume of rectangular prisms. So, we want to reduce the volume of the box by a scale factor of 1/2. So if we want to reduce the volume, it might be helpful to actually calculate the volume. So remember what I told you before. If the length, the width, and the height is not labeled, then put an L next to the length, a W next to the width, and an H next to the height. And then we always write our formula, length times width times height. And we put an L next to the 4, we put a W next to the 2, and we put an H next to the 6. So we're doing 4 times 2 times 6, and that is 48, and our label is meters cubed. Okay, volume is always cubed. Okay, now, we need to list all 3 options by calculating the new volume. Okay, and look at the original question. It said reduce the volume of the box by a scale factor of 1/2. So if the original volume is 48, what should the new volume be if we cut 48 in half? And hopefully you said 24. So all our new volumes are going to be 24. So 24 meters cubed. And once we put our measurements in, we'll double check that they multiply to give us 24. Because if they don't, then we made a mistake. So remember, the last question said we can only change one measurement at a time, or you've also heard me refer to it as attribute. So we can only change one attribute at a time. So either the length, the width, or the height. So since in this chart the length comes first, I'm going to change that one first. So look at the original length. You see that it's 4, and we're going to do a scale factor of 1/2. So what's half of 4? That's correct. It is 2. And if we changed one attribute by 1/2, the other ones need to remain the same. So the original width is 2 meters, and the original height is 6 meters. And let's verify that it gives us 24. 2 times 2 is 4. 4 times 6 is 24. So yes, those measurements are correct. So we changed the length, so the next one is to change the width. So the original width is 2. Half of 2 is 1, so I'm going to write 1 meter. The original length is 4, so write 4 meters. And the original height is 6 meters. So let's verify that it multiplies to give us 24. 4 times 1 is 4, and 4 times 6 is 24. So that's correct. And we've changed the length, we've changed the width. So the only other option I have is to change the height. So the original height is 6. So what's half of 6? That's correct, 3. And now I need to fill in the original length, which is 4, and the original width, which is 2. And let's verify. 4 times 2 is 8. 8 times 3 is 24. So now, if you look at this, we have 1, 2, 3 sets of measurements. So remember that when you're doing your exit pass. And also think about how many attributes we changed each time. So here, we only changed the length. Okay, so we can put an L here. We only changed the length. Here, we changed the width. And here, we only changed the height. So if I ever asked you how many attributes do you change at a time, you would say 1. Because here we change the length, that's 1. Here we change the width, which is 1. And here we change the height, which is 1. So we only change 1 at a time. So if we want to cut the volume in half, we only change 1 attribute. So that concludes part 1 of our volume of a rectangular prism notes. Have a great day.